I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to discuss the topic on review of vector algebra for the course Electromagnetic Fields and Waves. So let us discuss about the previous concepts in electromagnetics. The electric field, it is exerted by stationary electric charges which create force on other charges. So next is the magnetic field and generated by moving electric charges, that is the direct currents. So electric field is denoted by the letter E, magnetic field is denoted by the letter H. And the interconnection between these two fields are a changing electric field creates a magnetic field, and a changing magnetic field creates an electric field, which allows them to propagate as an electromagnetic wave such as light, radio waves, etc. And next is the topics for today's discussion is scalars and vectors, vector notation, vector operations, and also the applications of vector algebra. So now the empathize part in design thinking regarding the topic vector algebra. So first we should understand the need of vector algebra. So vector algebra is used in electromagnetic fields as electric and magnetic field have both magnitude and direction. And these vectors allow compact representation of fields which simplify the calculations and also visualizing the interactions. And this vector algebra describes how fields change in space and time. So this is the empathy part of vector algebra. So next comes to the second stage of design thinking. It is a define part. So we are going to compare the vector and scalar quantities. And the scalar, we know it is the magnitude only. And the examples of scalar quantities are mass, time, temperature, voltage, electric charge, etc. And vectors are having both magnitude and also directions. Example, we can say the displacement, force, electric and magnetic fields, velocity, etc. So vector notation. So always a vector can be represented with a tail is a start point and a head is the end point. It is an arrow mark, and the length represents the magnitude, that is the size. Arrowhead represents the direction of the vector. And now coming to the ideate part, we are going to see the different type of vector operations, vector addition, vector subtraction, and the vector multiplication. In vector multiplication, there are two cases. One is the dot product and another one is the cross product. So now the vector addition is adding two vectors, and the magnitude direction of the vectors must be considered in this case. And this can be given by a vector plus b vector gives another vector called c vector. And it obeys commutative property, that is a vector plus b vector is also equal to b vector plus a vector. And now vector subtraction. So two vectors can be easily subtracted using vector addition rules. So here a negative vector is considered as a vector with an opposite direction. So now the multiplication part. So first we are seeing the scalar product or dot product. So the scalar product of the given two vectors a and b is given by the equation a dot b is equal to magnitude of a, magnitude of b, cos theta. So here the theta is the angle between the two vectors a and b, and this dot product indicates how much the vectors point in the same direction, resulting in 0 if they are perpendicular. So if the two vectors are perpendicular, we can take dot product and make it as 0. And next is the cross product. So this binary operation on two vectors that results in a new vector perpendicular to both original vectors. So considering two vectors as A and B, its cross product can be given by A vector plus B vector is equal to magnitude of A multiplied by magnitude of B multiplied by sine of the angle theta. Theta is the angle between the two vectors. So now the real-time applications of vectors. Vector can be useful in power engineering, which enhances the energy distribution, and also useful in modern wireless technology, medical and diagnostics. So far we have discussed about the review of vector algebra. In this, we have seen the recall, that is the background context, and next we differentiated vector and scalar quantities, and the importance, empathy part, why vector algebra is so much important in electromagnetic fields, and we have seen the notations used to represent the vector operations, and also the real-time applications. Thank you.